Hi, my name is Chris Flynn and this is my final assignment for phys1160. Before galaxies, there are protogalaxies, or protogalactic clouds. They are tricky to detect, as there is only a faint emission of ionized hydrogen that indicates their position, which pushes our measurement instruments to their limits. As gases collapse inwards, massive amounts of starburst activity occurs. The presence of angular momentum and the density of these gases ultimately determine whether protogalactic clouds emerge from this early stage as elliptical or spiral galaxies. After the first gigayear of life, the evolution of a galaxy slows significantly. Interactions with other galaxies becomes the major influencing factor, driving further growth through mergers, shaping the galaxy's structure and star formation activity. The spiral galaxies in the Coma and Hercules are mainly blue, due to the intense starburst activity occurring in their spiral arms. Contrasted with the orange glow of their elliptical counterparts, it seems unlikely that there is any starburst activity occurring there. I would imagine that the elliptical galaxies are older, as their starburst activity has ceased. Similarly, the central bulge of spiral galaxies in these regions appears to be much closer to that of the elliptical galaxies, indicating that at these central locations in the spiral galaxies, there are stars that are much older than the young, hot, massive stars in the surrounding disk. The collision event of NGC 6745 shows a massive amount of starburst activity in what appears to be the beak of the bird. This is very clear from the volume of massive blue stars clustered on the edge of the galaxy, displaced from what appears to be the two curved spiral arms where stars previously must have formed. This tells us that when galaxies interact, the massive amount of gravity between them causes gases to collapse inwards at the point of collision, causing this intense starburst activity to occur, much like in the formation of protogalaxies. The galaxy cluster images show a trend where, in the central mass, it's typically dominated by elliptical galaxies, with spirals occupying space much closer to the edge of the frame. The spiral galaxies are significantly less in number in all cases, which tells us that the result of collision events typically leaves an elliptical galaxy where the spiral arms are consumed or destroyed in the interaction. The ultra-deep field view of the Hubble telescope presents a much more balanced perspective than the galaxy clusters. The distribution of galaxy types is much more even, which is expected to be, as on large enough scales, the universe is homogeneous and isotropic. If we could take this Hubble ultra-deep field image in 10 billion years' time, I would expect it to be a distribution much closer to that of the galaxy clusters, with more elliptical galaxies than spiral, resultant of the collision events occurring between now and then. My biggest takeaway from this experiment was garnered from the NGC 6745 photo. I had previously considered the interaction between galaxies to be much more of a destructive event, but from the image it's very clear that there is much more creative, intense activity resulting in the new formation of stars that couldn't have previously occurred. The particular visual representation of this event really changed my perspective on what galactic evolution really looks like.